Okay, now let's use the timeline, and let's use it to reveal the power of parametric modeling. Fusion is a parametric modeling tool, which just means that you have parameters, and as you change them, those changes ripple through your model, regardless of when you make those changes in the timeline. So what's a parameter? Let's look at some. Double-click on your sketch in your timeline to travel back in time into sketch mode where we can edit some of the parameters. Look at the edges of my rectangle. Each edge is a parameter. Look at how wide my rectangle is. If I make my rectangle wider, I have changed some of those parameters. And notice how if I come out of sketch mode by clicking on the Finish Sketch button, having changed the parameters, my entire 3D model has changed. It's gotten wider. This is the ripple effect. A change to a parameter back in time ripples forward, changing everything that it affects. Let's play with some more. Double-click on your sketch to go back into sketch mode and make your rectangle thinner. Click Finish Sketch and see how your 3D model has gotten thinner as well. If I make both dimensions smaller, my 3D model gets smaller. Now let's play with a different parameter. Double-click on your extrusion in your timeline and find the distance parameter, and change that to 1.0. And notice how your 3D model gets shorter. Click OK to confirm these changes. Double-click on your sketch one more time, and now let's dimension some of these parameters. Dimensioning a parameter means precisely defining it with a number. And it's not just precision, it's also the notion of locking part of your sketch into place so that it doesn't change anymore. How do you do it? Click on the Dimension tool, come down to this top edge of your rectangle, and click on it using the Dimension tool, and then move your mouse up and place your dimension somewhere above your model. Notice this number with all of these digits after the decimal point. I wouldn't call this precision. I would call this the randomness of where I happen to stop dragging that edge earlier. Precision to me is precision to a set number of significant digits to the right of the decimal point. So let's set our precision at 2 significant digits to the right of the decimal point and dimension this edge to be 1.00 inches, with the notion that those zeros are significant. This lets us communicate to each other loud and clear that 0.00 is not the same as 0.01. Those numbers have a significant difference between them. And it also lets us communicate that 0.00 and 0.001 are close enough that we can essentially ignore that third digit. It is insignificant. Who gets to decide this issue of significance? Well, it kind of matters what you're making. So for now, let's just start with 2 significant digits. Good. Now that you know how to dimension one edge, let's dimension another. Make sure that you are still using your dimension tool and click on this right-hand edge and place your dimension and set it to be 1.00 inches. Okay, click Finish Sketch, and you should be looking at a perfect cube, 1 inch by 1 inch by 1 inch. Come up here and click on your measurement tool so that we can ask some questions about this cube to confirm with precision how big it really is. With your measurement tool, click on this vertical edge and see that the measuring tool shows a length of 1.00 inches. Click the blue arrow to clear that selection and click on a different edge to show that they are all 1.00 inches. Clear that selection and click on these 2 parallel edges. See how you can use the measuring tool to measure the distance between 2 edges. Clear those 2 selections and then click on this top face, orbit the view, and click on the bottom face. Notice how you can measure the distance between 2 parallel faces. We've made a perfect cube, so all of these measurements should show as 1.00 inches. If any of your measurements show otherwise, take a moment to pause and figure out what's going on. If you can't make consistent measurements at this point, it's really not worth moving on to more complicated geometry. Good. Click this close button to end your use of the measuring tool. Let's tidy up one final detail. Notice how my cube is floating a little bit off to the side on the x-axis and a little bit down on the y-axis. This is not yet tidy. Let's position one corner of our 3D model at the origin of the world. And to do so, I'm going to double-click on my sketch to come back into sketch mode, and I'm going to click on this lower left corner, and I'm going to drag and wait for it to snap onto the origin of the world. The origin of the world is just the point in space where the x-axis and the y-axis meet. Why bother tidying up your models in this way? Well, click on that measuring tool again and click on this point. Notice how its x, y, and z position are all 0, 0, and 0. This means that I can click on other points and see a nice, easy to understand bit of position data. Click on this point up here in the upper left and notice that its y position is at 1.0. Clear your selection and then click on this point down here in the bottom right and notice that its x position is at 1.0. Clear that selection and click on this point in the upper right corner and notice that the x and the y are both at 1. If any of your numbers are different from these and you can't figure out why, take a moment to ask for help. It's really worth solidifying this moment before getting complicated. Okay, one last bit of data. Click Finish Sketch to come back to your 3D model. And with your measuring tool, click on these points on the top of your cube just to see that their Z position is at 1.0. Good. These are the absolute basics of CAD in 3D. Go ahead and save your file and call this version my 1x1x1 cube. Look over here in your data panel and notice how V1, version 1, becomes V2. And if I click on V2, I can see all of my versions, my blank file that I started with, and now version 2, my 1x1x1 cube. Every time you save your work, Fusion versions it so that you always have the chance to go back in time to various save points if there's something back there that you want to go get. Good. This is a bit of a fork in the road where you can either get better at CAD or you can start learning CAM, computer-aided machining. If your goal is to 3D print these objects, then you might want to focus your next step on getting better at CAD, computer-aided design. If your goal is to machine precision metal parts in a CNC mill, then I would recommend your next step be to say hello to the very basics of CAM, computer-aided machining.